All right, there's a second concept in 4.3. So we did conditional probability in the last video. This one is at least one probability. It'll be in the homework and things, and there's a nice clear way to do it, and ideally it makes a lot of sense. So let's suppose that we have 5 people, and I want to know the probability that at least one let me think about something. At least one is, let me just do this. We don't have to deal with the numbers. Probably at least one has green eyes. Okay. So maybe they tell us, hey, we have 5 people, and the probability that an individual person has green eyes is 0.02. Okay, it's going to be low. Now, we don't see a lot of green-eyed individuals in our day-to-day contacts, but I'm making it up as 0.02. So they're going to ask, hey, what's the probability that at least one of these 5 have green eyes? Now remember what that means. That means 1 could have green eyes, or 2 could have green eyes, or 3 could have green eyes, or 4 could have green eyes, or all 5 could have green eyes. Well, that's a lot of different choices there. Each one of those would have to be figured out separately. So that is 5 individual calculations that you would then have to do a 6th calculation to add up. There's a better way. So if you think about all the possibilities of number of green-eyed people, all 5 having green eyes, 4 having green eyes, 3 having green eyes, 2 having green eyes, 1 having green eyes, there's one that's being left out, and that is 0. 0's on the outskirts. So we might as well use that. So the probability of at least 1 is always done the same. 1 minus the probability that none have green eyes, or in this case have green eyes. But this is the general one. So if you're doing a probability of at least 1 and not doing it 1 minus the probability of none, you're probably doing it wrong. You actually need some formulas from chapter 5 in order to do that. And so we don't want you to use that formula because there's an easy way out. Even if you had those formulas from chapter 5, you would have to do 5 of them and a 6th calculation to add them all up. This is 1 calculation to find the probability and a subtraction, and you're done. So for us, the probability of at least one of the 5 having green eyes is simply found by 1 minus the probability that none have green eyes. Let's think about that. That's 1 minus, well, we want the first person not to have green eyes. So if we come back up here to the probability, this is the probability that they have green eyes, so the probability that they don't have green eyes is 0.98. Everybody comfortable with that? So the probability that they have green is equal to 0.02. So the probability that they don't have green is equal to 1 minus 0.02, or 0.98. And the probability that the second one doesn't have green eyes is also 0.98. The probability would not change, and that would happen all 5 times. And so all we have to do is grab a calculator and type in 1 minus 0.98 to the 5th. And I didn't hit minus, I hit plus. I was like, what is that? And you get a 0.0966 0.07, so 61. So a 0.0961 probability. So it's not unlikely to have at least one person out of a group of 5 in this population having green eyes. It's going to happen about 9% of the time that you bring those groups of 5 together. That's how we're reading this information. But it's not unlikely because it's above 0.05, so they may still filter in those types of questions as we go through. So we could say something like this: a couple plans to have 3 children. Find the probability that they will have at least one girl. So they want to make sure they have a girl, right? And then what's the probability that they have at least one girl? Well, the probability of at least one girl will be handled how we're going to handle every at least one probability. Immediately a 1 minus the probability of no girls. So let's keep our 1 minus, that's stagnant. How about the first one not being a girl? If it's not a girl, it's a boy. What's the probability of a boy, assuming boys and girls are equally likely? It's 1/2. Probability of having the second child not be a girl but be a boy is also 1/2. And the third. So you have 1/2 times 1/2 times 1/2. They'll always be like this. We have the same number repeated. So now we just have to take 1 minus, and remember to put your 1/2 in parentheses, to the third. And we have a very high probability, 0.875. Now why did I choose this one? Because it matches examples done for you by me and also by the book. Remember, we did this via a sample space before. And if we recreate that sample space, and just go really quickly and recreate this sample space, let's go highlight the ones that are at least one girl. So this one has, oops, sorry, I grabbed the eraser and not the highlighter. This one has at least one girl, this one, all of these have at least one girl. The only one that doesn't is this last one. So this is how we were figuring out in 4.1, we absolutely needed to see the sample space. Now we don't. We're relying upon the probability of an individual child being a boy or a girl as 1/2. And so what do we have? We have 7 out of 8. Take a look at what 7 divided by 8 is on your calculator. It's the exact same 0.875. Of course it's going to match, right? But that's why I grabbed that one, is because there'd be reinforcement. This is what they're going to have in there. They will have problems like this too. Vitalant is a company that handles blood donation. They test blood for HIV by pooling together blood samples from 4 individuals. Okay, so if you and I were to go into BloodSource, I apologize, I'm calling it its new name now, Vitalant. If we were to go into Vitalant, they would tell us that as part of our blood donation procedure, they will be testing our blood for infectious diseases, including HIV. And so they don't do that by testing individual blood one at a time. They put it together and then run it together. The mixture will test negative if all samples are negative. If the probability of an individual sample being positive is 0.01. Right? I want to make it somewhat unlikely. Find the probability that the mixture will test positive. And so here's where we think, and this is the intent of this course, is really to get you to think and apply knowledge. So what we have to think about here is what's being said. Let's go straight to the question. The probability that the mixture is positive, right? Test positive. Well, how is that mixture going to test positive? They don't tell us directly, but they kind of tell us. They tell us that it's going to test negative if everybody's negative. So what if one of the four is not negative? Well, then it's going to test positive. If two of the four are not negative, then it's going to test positive. If three of the four, and so forth. So really, it's going to they want us to find the probability that at least one of the samples, one of the four samples, is positive. That's how it's going to test positive, if at least one of them is positive. Well, we know how to handle at least ones. 1 minus the probability of none being positive. So none of the four being positive, meaning that they're all negative. So this is 1 minus the very first person's blood testing negative. Well, that's going to be 0.99. And the second person, also 0.99. You okay with where I'm getting the 0.99? I know the probability that an individual is positive is 0.01, so the probability that they're negative is 0.99. And that's what I want. I don't want it to be positive. None are positive. They're all negative. So this 99 is going to happen all four times. And if you look at 1 minus 0.99, to the fourth, we get this, 0.0394. So only about 4% of the time are they going to have to stop and test everybody's blood, because what's happening is 96% of the time, right, because we're almost to 4%, the mixtures are testing negative, and it clears all four samples. Clear it. And then occasionally, about 4% of the time, they will have a mixture that's positive. When that happens, they don't know how many in there are positive, and so they got to test those fours. But think about the effectiveness of that. They're getting rid of 96% of the individual blood samples that they need to do, and only dealing with about 4%. So that's awesome, and it's used in other businesses as well. This is just one we can easily wrap our brains around. But you'll look, I call this a hidden at least one, because nothing in the question talks about at least one. And you'll see that happen in a couple of questions in the homework and most likely on the exam. But then there'll be ones that are very overt. Hey, what's the probability that we have at least one girl? What's the probability that at least one has green eyes? And you just want to remember the trick. The way to handle the probability of at least one is in the most efficient way that you can. 1 minus the probability of none. Why figure out 1, 2, 3, 4 when you can just figure out 0 and be almost finished? And so that's the idea behind that. So give that a shot in the homework, and I hope it goes well.